Hey kiddos, today we are going to discuss inductive and deductive reasoning. All right, so continuing on with logic. All right, so again, if you haven't already realized it, this logic unit is very vocabulary heavy. I know that you guys aren't really into vocabulary, but you got to know it. So, conjecture is an unproven statement based on observations. If a conjecture is true, it must be true for all cases. Inductive reasoning, finding a pattern. Okay, so that's the key word here that you want to make sure you correlate with inductive reasoning. Okay, finding a pattern and then using those observations to write a conjecture. A counterexample is a specific case for which the conjecture is false. Okay, can show that a conjecture is false by finding just one counterexample. So if there's one example, sorry about that. We had to pause to do the pledges. So as I was saying, so if you're able to find one example that'll prove something false, prove something wrong, then that's basically what we call a counterexample. Deductive reasoning, okay, uses facts, definitions, accepted properties, and laws of logic to form a logical argument. So it is different from inductive reasoning, which uses specific examples and patterns, okay? So inductive reasoning, key thing here is patterns. Deductive reasoning comes from facts. All right, so describing a pattern, okay? So practicing some inductive reasoning. Describe the pattern. Then write the next two items in the pattern. So here is our first example. We have 1, -2, 4, -8, 16. So hopefully what you guys are noticing is that we are multiplying it not just by 2, but by -2. That's how we're able to get the combination of positives and negatives in between. So to figure out the next two items, we're going to take 16 times -2. 16 times -2 gives us -32. So that's the first part. And then to figure out the next one, we would take -32 times -2. That's going to give us a positive answer. That is going to be positive 64. All right, moving on. So next example, looks like we're talking about the days of the week. So you got Monday, Tuesday, Wednesday, Thursday, Friday, and of course, I'm saving the best here, the weekend. So the next two items in the pattern would be Saturday and Sunday. All right, so again, more examples on patterns. Sketch the fourth figure in this pattern. Okay, so notice first figure, we have a circle cut in half. Then we have a circle cut into fourths. Notice in each one of these, one section is also being like highlighted or colored in. Then we have it sliced into 6 pieces with one section colored in. So I'm guessing this figure is going to be sliced into 8 pieces and also have one section colored in. All right, so sketch the fourth figure in this pattern. So I notice we start off with one circle. Then here we get 3 circles. Notice 2 circles on the bottom, 1 at the top. Then we go from that and we go to 6 circles, 3 at the bottom, 2 in the middle row, 1 at the top. So I'm thinking our next one is going to have 4 rows with 4 circles on the bottom, 3, then 2, and then 1. All right. Making and testing a conjecture now, okay? So we're still talking about inductive reasoning here, all right? Numbers such as 3, 4, and 5 are called consecutive integers, okay? Consecutive because they follow one another. So make and test a conjecture about the sum of any 3 consecutive integers. So my conjecture here, we can state, and let's see, I'm going to say that the sum of any 3 consecutive integers is 3 times the second number. All right? Now, my evidence, okay? So let's actually work this out. 3 plus 4 plus 5 equals 12. And I'm saying, based on my conjecture, that the sum is always going to be 3 times the second number. Well, in this case, 4 is the second number. So if I take 3 times 4, do I get 12? Yep, so far so good. But let's try another set. I have 0, 1, and 2. Consecutive numbers, 3 of them. 0 plus 1 plus 2 equals 3. All right. I notice that our middle number here is going to be 1. Sorry, our second number is 1. So according to the rule, 3 times 1, that's what my conjecture states. If I have 3 times 1, that equals 3, which is the sum. So far, so good. Let's just try another one. Why not? We got 10, 11, 12. So 10 plus 11 plus 12 gives us a grand total of 33. Now, the conjecture states that we take the second number, which in this case is 11, and we multiply it by 3, and we'll get the same sum. So 3 times 11, well, what do you know? It is 33. So therefore, this is true, okay? And that's how you test a conjecture. All right, let's look at another problem. Make and test a conjecture about the product, okay? Product means multiplication, okay? Product of a negative integer and a positive integer. So what happens when we multiply negative and a positive? Our conjecture, let's see. Let's state the product of a negative integer and a positive integer is negative. It's always going to be negative. All right. Well, let's have some evidence here to prove it. So I picked 6 times negative 2. 6 times negative 2, positive number, negative number. Okay. Negative 12. Next example, negative 10 times positive 10. Negative times a positive, and the answer is a negative 100. So far, our conjecture, we're 2 for 2 here. Let's try one more. Positive 1 times a negative 3 equals a negative 3. Notice our answer again is negative, and that's what our conjecture is stating. So our evidence proves our conjecture true. All right, now finding counterexamples. So counterexamples are basically ways to prove it wrong, essentially, okay? So a student makes the following conjectures about the sum of 2 numbers. Find a counterexample to disprove the student's conjecture. So this is what the conjecture is. The sum of 2 numbers is always more than the greater number. All right? So I've picked 2 numbers. 2 plus 2. Okay? We should all know that 2 plus 2 is 4. All right? Now, the biggest number from 2 plus 2 is 2. And they're saying that the sum of our answer here is going to be always greater than the value of the biggest number. So 2 is the number. Is our sum bigger than 2? Essentially is what we're asking ourselves. And in this case, that is actually true. So I just found an example. I proved their conjecture to be right. So let's see if I pick another number. Now, nowhere in here does it say that we can't have a negative number. Okay? So I'm going to go positive and a negative number. 2 plus negative 3. 2 plus negative 3 is negative 1. Now, of the 2 numbers, 2 and negative 3, which one's the biggest? 2 is the biggest number here. So we're comparing the biggest number, which is 2, with the answer, which is our sum here, okay? That's what we're comparing. So when we compare those, according to the conjecture, this number should be greater than the sum. I said that backwards. I lied. I said that backwards. That the sum should be greater than this number. My bad. So, what you should notice is that is actually not accurate. -1 is not greater, okay? That is not true. That is not greater than +2. So this would serve as our counter example, okay? All right, so let's look at another example. The sum of two numbers is always greater than their difference. Okay, so meaning that if we add two values together, that answer is always going to be greater than if we subtract them instead. Okay, that's basically what this conjecture is stating. So here's an example I picked. I got -5 plus a -3. So notice we got to add them first. Okay, when we add -5 plus -3, we get -8. And it's saying that this value, okay, this answer that we got here is supposed to be greater than the difference. Now, let's actually do the difference of them. So, in other words, -5 minus -3. Well, if you know your rules, you know that minus a negative actually turns it into a positive. So, we actually have -5 plus a +3, and that actually gives us a -2. So, if we compare these two numbers, okay, -8, which was the sum, okay, and -2, which is the difference, according to this conjecture, this value is supposed to be bigger, greater than the difference. Hopefully you guys know, and if you have to draw yourself a nice little number line, you know -8 is definitely not bigger than -2. All right, so this is where -2 would be. This is where -8 is. Notice -8 is definitely not bigger than -2. So -8 is greater than -2. That's what they say, but we already know that that's actually technically not true. All right, comparing inductive and deductive reasoning. Okay, so decide whether inductive reasoning or deductive reasoning is used to reach a conclusion, and then explain your reasoning. So, A. Each time Monica kicks the ball up in the air, it returns to the ground. So the next time Monica kicks the ball up in the air, it will return to the ground. Inductive, deductive. This is a inductive reasoning problem. And the reason why is because Monica has discovered a pattern. She has discovered a pattern to reach her conclusion. She notices that if she kicks the ball in the air, it comes back to the ground. So if she kicks the ball in the air again, it's going to come back to the ground. So she's discovered a pattern here. So that is inductive reasoning. All right. All reptiles are cold-blooded. Parrots are not cold-blooded. Sue's pet parrot is not a reptile. Inductive or deductive reasoning? This is going to go towards the deductive side. The explanation, the reason why it's deductive, facts about animals are used to reach the conclusion. It is a fact that reptiles are cold-blooded. It is a fact that parrots are not cold-blooded, so therefore, Sue's pet parrot is not a reptile. Facts. Deductive. All right, next one. If the sum of the digits of a number is divisible by 3, then the number is divisible by 3. The sum of the digits of the number of 147 is 12. So basically what they're saying is if you add 1 plus 4 plus 7, you get 12, okay? Just FYI. So the number 147 is also then supposed to be divisible by 3 according to this. So inductive or deductive. And I know most of you guys are probably out here trying 147 divided by 3. Is that right? Oh, it is divisible by 3. So this is going to be a, deductive reasoning. And the reason why it's deductive is because facts are being used to reach the conclusion. All right. Next example. Each time you forget to do your math homework, your parents take away your phone privileges for a day. So the next time you forget to do your math homework, you will lose your phone privileges. Hopefully you recognize that this is inductive reasoning, okay? Our explanation, well, there seems to be somewhat of a pattern being used here to reach that conclusion, right? Every single time you forget to do your math homework, your parents are taking away your phone, okay? So you should know that if I don't do my math homework, parents are taking away my phone privileges. So notice that's a pattern that's being used, so that has to be inductive reasoning. I wonder what triangle is missing. All right, next example. Use the information given in the table. So, in order to make a conjecture about the relationship between x and y, we kind of need to understand what's happening here. Usually, when we look for a relationship between x and y, what we're looking for is a slope. What's the relationship between the two? So, I'm going to identify our slope, and our slope is basically y over x. So, the difference or the change in y divided by the change in x. So, basically, from -1, how are we getting to 3 is what we're looking for. Hopefully you notice that would be -1 plus 4 gives you to 3. And that pattern should stay consistent throughout this whole thing. 3 plus 4 does give you 7. 7 plus 4 gives you 11. 11 plus 4 gives you 15. So my y value is changing at a rate of plus 4. Now our x value is changing by adding 1. 0 plus 1 is 1. All right, so that's pretty straightforward on how the change is occurring. So it's 1. So my slope, in essentially 4 divided by +1 is going to basically be just 4. So I know that my slope is 4. Hopefully you all recall that y-intercepts are when your x value is 0, which is actually given to us in this table. So you automatically know your y-intercept is -1. All right. So make a conjecture then about the relationship between the value of x and y. Well, we can state that the value of y is 1 less than 4 times the value of x. So that kind of comes from y equals 4x minus 1. All right, that's where I'm getting that conjecture from. All right, so the value of y is 1 less than 4 times the value of x. So, well, I think I just answered question B. Write an equation for it. Y equals 4x minus 1. All right, so part C here says, use the equation to determine the values of y for x equals 48. So essentially where x is, we're going to change it to a 48. So it's called substitution. So y equals 4 times 48 minus 1. All right, so you got to do 4 times 48. It's 192. 192 minus 1 is y equals to 191. All right, so that is all, folks, for our lesson on logic. Adios.